Now in Lesson 2 of Module 6, we're going to be looking at what is called exponential functions. Now, when we deal with exponential functions, one of the best methods of looking at them is to graph them. And in your math lab, what you'll be doing is often selecting something from a multiple choice where they have 4 different graphs and they're asking you to pick out the one that it is. So by knowing the general process, then that should be helpful in having a toolkit in which you can then later pick out the correct graph. So that's what we're going to be doing here initially. And we are asked to graph this. Now hopefully I'm going to prepare a worksheet for you that you can then attach to your booklet, in which you will have some graphs available to you. You can take some notes in your booklet and also use this worksheet as we go along. So we'll move it up a little bit so we get to just the graphs that we want. Now what I'm going to do here is set up some t-charts, and you should do this on your paper as well. So there is the start of a t-chart, and we're going to put our x values there, our y values there, and again our equation is y equals 4 to the x power, and we want to graph that. So again, if you put this in your calculator, you're going to get the graph. But here we're going to put it in our calculator, and I should say our t-chart. We're going to put values in our t-chart that will generate some points on a graph that we can then use to graph this function. So the points we're going to use is a 0, a 1, a -1, a 2, a -2, a 3, and we could do a -3 as well. Just extend that a little bit. Now, as we do this, again, be sure you're understanding what's going on. So I'll put the values of y in blue. So if we have 4 to the 0 power, any number to the 0 power is 1. Now 4 to the first power is 4. Now 4, let me write that over here. 4 to the -1 power, we had said that it's 1 over 4. This just goes down to the denominator, and in a sense 4 to the -1 is just the reciprocal of 4, so it's 1 over 4. Now 2x to the second power is 16. Now the reciprocal of 1 over 4 to the second, when we bring that -2 down to the denominator, it becomes 4 to the second down here, and 4 to the second is 1 over 16. In a sense, the reciprocal of it. Now this next one is 4 to the third power. Numbers get pretty big fast. This is 64. And the reciprocal, when it's 4 to the -3, is 1 over 64. So we're seeing a little pattern here. And that's the graph they ask us to graph here, that we'll do here shortly. Now, another thing that I often like to do is to show you a little bit on how these graphs work. And where this is y equals 4 to the x power, how about if we have this one, y equals 3 to the x power, and have this one, y equals 2 to the x power, and we're going to put our same values there in each one of these. Now they don't this is not B or C. This is still relating to A. I'm just using this room here. What would those values look like? So let's set that up. Now in the function y equals 3 to the x power, we're going to fill this in, again using the same values. So 3 to the 0 power is 1. Anything to the 0 power is 1. Now 3 to the first power is just 3. 3 to the negative 1 power is going to be the reciprocal, 1 over 3. 3 to the second power is 9. So to the negative 2 is a reciprocal, or the reciprocal, 1/9. And then 3 to the third power is 27. And this would be 1 over 27 if we had that, and we could just stick it there. Okay. Now let's work this one. This is y equals 2 to the x power. Our base is 2, so this is the exponent. If the exponent is 0, anything to the 0 power is going to be 1. I'll put that in black. 2 to the first power is 2. To the negative 1 power is its reciprocal, 1/2. 2 to the second power is 4. 2 to the negative 2 power is a 1/4. It's reciprocal. 2 to the third power is 8, and 2 to the negative 3 power is 1/8. So we now have 3 values in which we have y equals 4 to the x, 3 to the x, 2 to the x. Now I'm going to plot these on these 3 graphs right now, and I think what we're asking you to do is plot all of them on one graph eventually, and that'll be for your notes, and then we'll just label them so you'll have an idea when you're asked to graph this type of function what it will look like. So since I have the black one here, let's plot this one. When this is y equals 2 to the x power. So when x is 1, here it is, x is 1, y will be 2. Well, we're going to do the 0 first. When x is 0, that would be right here. Okay, there's our first one, right there. Now, when x is 1, y is 2. So over 1, up 2. Now this next one is when x is 2, 1, 2, we go up 4. 1, 2, 3. Did I do 2? Oh, I went up. Let me fix that here. So to save us a little time, we did these positive values. Well, 0 is not signed. Then x is 1, so that's 2 to the first is 2. 2 to the second is 4, and 2 to the third is 8. Now we have some negative values here, but these are a little jammed in. It would be 1/2, 1/3, 1/8. And these get closer and closer to your x-axis, but never reach it. Do you remember what we call that? That was your asymptote. When a line gets close to something but never reaches it. Okay, so I'm going to just sketch this in now using my super artistic techniques of connecting these dots here. Okay, not too bad. So what is this the graph of? This is the graph of y equals 2 to the x power. Here's your t-chart with points, ordered pairs, coordinates, and this is the graph. Now, in blue, I'm going to plot these, which is y equals 3 to the x power, and there are our values. Now, this one, I'm putting y equals 3 to the x power on this graph. So again, asymptote gets like so. It goes through 1, but now it goes up to 3, and it goes up to 9. So I don't know if you notice this, but this line is getting closer to the y-axis. All right, now let's plot this one. Okay, I finished these up a little bit. So here is the curve for the function y equals 3 to the x power. And here is the curve, the actual one we're supposed to be doing in this mini lecture, y equals 4 to the x power, and that's this red line. Now, I don't know if you notice now, once again, that as the numbers increase from 2 to 3 to 4, that this line gets closer to the y-axis as you go from 2, because your values as you square these numbers get larger. So it brings it closer to the y-axis. And that's an important trait that when you're picking out through multiple choice which value they are asking you to graph and what it looks like. Okay, I'm just going to show you one other thing before we go on. What I've put into my Mathway program, y equals 2 to the x, 3 to the x, 4 to the x, and I'm going to ask it to graph, solve by graphing, and then I'm looking for the answer. Well, for some reason they wouldn't solve them all together, but there is the graph of y equals 4 to the x power. And again, when x is 0, 4 to the 0 is 1. Everyone is 1. Any power to the 0 power is 1. And then it goes up to 4, then up to 16, and looks like this. The others, I wanted to show you that as we did these and the numbers grew from 2 to 4, as the numbers got bigger, it went from 2 out there to 3 in there, and then to 4. And if it was 5 to the x power, the lines would be closer still. But the points on this line would never reach it, because, as we say, our x-axis happens to be the abscissa. And the equation of this abscissa, by the way, that is, what would be the x-axis is a horizontal line, that y equals 0. So when y is 0, that is the x-axis. And that happens to be the abscissa of this particular graph. Okay, again, we just have to recognize it, and I may be giving you too much material. Now, again, we just have to recognize what's going to happen when this is the original function, and now we take the reciprocal of this, flip it over, and we get 1/4 now to the x power. Well, we're going to fill these values in, and I'll let you have a shot at it first. Okay, taking a moment now, taking a look also at what we had here. I put this up again. So whenever x is a 0, y is always going to be a 1. But now here, when it was a 1, here it's a 1/4. Here where it's a -1 was 1/4, a -1 here is 4. So I don't know if you can see they're sort of like the opposites of each other as we look through what we have here. So let's graph first this one, and then we'll put this one on the same graph. We'll put this one in black. So here we have a 1. When x is 0, y is 1. When x is 2, or I should say when x is 1, y will be 4. When x is 3, well, let's do 2 first. We're going to go up to 16, way up here. So this is the, and then this curve just goes down here like so. And this is like so. To contrast, I'll put this one in red. Y is equal to 1/4 raised to the x power. So when x is 0, anything to the 0 power is 1. So that's going to go right here. Now, when x is a -1, it's 4. So over 1, it's right there. When x is 2, it's 1/16. So -2, 1/16 is right up there. So our graph now looks like so. And when we get these values over here, you'll see they reflect. So these are mirror images of them. And we do have an axis of symmetry, which is the y-axis. But what is the equation of the y-axis? And the answer is x equals 0. So our horizontal asymptote is still the x-axis, which is y equals 0 for both of them. And the axis of symmetry, I see in my other, I didn't have room and I left out one of the m's, is the y-axis, but the formula for the y-axis is x equals 0, which is a vertical line going through 0 on your x-axis. Okay, so that was this one. We now have this one to do. So let's think about that. Now, this is another free calculator that's called Meta Calculator. I've put the first equation in, y equals 2 to the x power, and I'm using the caret sign. And then here I'm putting in y equals 2 caret to the x plus 1. So we're going to ask it to graph it, and then we can see what the two graphs look like. This is what I was looking for here. So, looking at this line right here, this is our first one, y equals 2 to the x power. Now when we add a plus 1 to it, what does it do? it shifts it up to this next position right above here. Okay, so I'm not going to graph it. This is a much better job than I can do. You just want to know what happens. Well, you can see my sketching isn't very good. So the red line was y equals 2 to the x, and the blue line is y equals 2 to the x plus 1. It shifted it from a 1 position to a 2 position, and that's basically what you want. Now, you could have made a little chart and you would have gotten these, but we've spent a lot of time now showing you what to expect and what the graphs look like. Now, in example 2 here, I don't know if you see it, but we've switched the letters around. We're looking for the inverse when we change the position of the x and the y. Now, we did this one above as an extra one, so let's fill this in again. And again, this is meant to give us a comparison of what these look like. So, plotting this, we know we have a 1 there. If x is 1, we have then a 3. And if it's 2, we have a 9. So our curve is basically like so. Now, what will these be? Now, when y is a 0, anything to the 0 power is 1, so this becomes 1. Now, if y is to the first power, 3 to the first is a 3, and if it's a negative 1, this is its reciprocal, 1/3. If y is 2, this becomes a 9, and to a negative 2, it's reciprocal, 1/9. And if y is 3, this becomes 27. And let's plot these now. X is 1, y is 0, so it's right there. If x is 3, 1, 2, 3, y is 1, right there. And let's do the 9 while we're here. If x is 9, which is out here, y is going to be 2. So this part of the curve looks like so, and this part, as it gets closer and closer, looks like so. Now, I don't know if you can see this, but what we did the other day, can you see that this is the inverse of this? This is what this graph is like, and this graph is this one. This is the inverse of this. Now, is there an axis of symmetry? And the answer is yes. Now, what is the equation, by the way, of this axis of symmetry? Well, it happens to be y equals x. That's the official equation of this axis of symmetry for the inverse function of this. So again, you are asked to do this when you have x equals 3 to the y power. Again, you switch the positions of the x and y, you get its inverse graph. And that's what you have to recognize. So again, in your notes, be sure you have enough information of what's going on here to be able to pick out. Now, suppose it was 2 to the y power. Well, that would be a little further away here. Would still go through 1, but it would look like so, or a little higher out actually. And if it were 4 to the y power, it would come in a little closer this way. And 5 to the y power a little closer. And 6 to the... But everything would go through 1, as it does here. Okay, again, some background so that when you do your mastery on MATLAB, you're able to use this as a reference and hopefully know what they're talking about. Now, in this last one, they're using this formula that we had used before. A equals, which is the end amount, the principal, and then 1 plus I, which is your interest, to some time value. So they want you to, if you start with 50,000 at 6% interest, develop these formulas and then put in these various exponential values to see what your answer would be. And you would just put this in your calculator. So let's set it up. So we don't know the amount here. We know our principal is going to be 50,000. Somebody has a lot of money. Times 1 plus the interest rate of 0.06. So actually I can just change that. Add these two together since we know what it is already. 0.06 first to the 0 power, then to the 3rd power, then to the 5th power, and then to the 10th power. Now I didn't fill in, but all of these is 1.06, 1.06, 1.06. Now, when you are starting off, that's your 0 amount of time. This is 3 years later, this is 5 years later, this is 10 years later. Now, for all of these, what you will do is put this in your calculator. In fact, this one you don't, because you can figure it out. What is anything to the 0 power when you start? It's just going to be the 50,000. Now, in doing these next 3, you put 1.06 caret 3 in your calculator and then multiply it by 50,000, and that will give you the answers. And these are all down below, and you should try them out to see if in fact you get these answers. Okay, I put these in my calculator and I got this. So you can check your work. Now, in putting this into a calculator to graph it, you would change this A to a Y equals, you put your 50,000 out here, and then times it by, in parentheses, 1.06, and just raise it to the x power, which is your time, and that will give you a graph. Okay, so again, lots of stuff going here, but I wanted to give you the background of how to graph exponential functions. And again, we're going to use this as we move into our future lessons. And there's only 4 remaining lessons in our Math 105M course.